All right, like I said, don't forget you got to create an imaginary class before it and after it that have frequencies of 0, right? Because any class before it would have a frequency of 0 because there's nothing there. Any class after would have a frequency of 0 as well because there's nothing there. Because that way your day is anchored. It won't be like something, it won't be floating in space. It'll be anchored up as the end.
Is it just done?
Although I don't know.
You might, yeah.
So you're going to find every single point.
Mark, I this one.
And you're going to put the midpoints along the bottom. And then above each midpoint, you're going to put a dot where the frequency is for that class. Oh, it starts where? On the left? Yes, that would be totally correct.
So you go all
Because
the
the
way
frequency
down.
polygon always has the height.
Okay.
So yeah, it's a good question. So the question was, if you put the frequency, if you put the midpoints along the left instead of on the bottom, is that incorrect? And that would be incorrect because frequency polygons and histograms always have the heights as the frequencies or relative frequencies. I'll do it later. Okay, so 22 is the midpoint for 20 to 27, sorry, 24, has a frequency of 7. The next class, 25 to 29, oh right, that has a frequency of, that has a midpoint of 27 and a frequency of 5, so 27, frequency of 5. Next class, 30 to 34, has a midpoint of 32, frequency of 3. 1, 2, 3. Oh, did I miss one in there? 1, 2, 3, 4. My bad. So that's in the wrong spot. That's 5. That's 7. So these are actually off a little bit. My bad. Sorry, let me do this again. So 4, 7, 5, 3. 0, 0, 1, 0. So then you're going to draw your line. Just like that. Good. Take a look. Okay, good. All right, so we're going to go and move on. But do you see how it's important that we anchor them in the bottom and the front so that so that it's not just floating in space, right? If I didn't have it anchored, it would just be floating in space. So that's why we have to anchor it in the front and the back, create those extra classes. Yeah?
Why is your second anchor at 50?
So it's anchored here. This isn't really an anchor. This is two classes that have 0 frequency.
Yeah, but why is it at 50 instead of 52?
Oh, because I made a mistake. Thank you. Excellent. Thank you for checking on that. Because again, I'll make mistakes and I'd rather you guys not be confused. So, appreciate that. All right, next. Ogives. These use the upper boundaries and either the cumulative frequencies or cumulative relative frequencies. Why is that? Okay, so ogives answer a different question. Very, very, very often, we want to know how many in a sample are less than or equal to or less than some number. Or sometimes we want to know greater than. But either way, but very often we want to know the cumulative up to that point. Like how many people are 5'2" or less? How many people ran 10 miles or less? Things like that. So here's a question. How many runners ran 8 miles or less? So how many runners ran 8 miles or less? One person said 1. Any other answers? Is it 1? Maybe 0? We don't know. Here's the problem. We know one guy ran between 5.5 and 10.5 miles. We don't know whether he ran 6 miles, 7 miles, 8 miles, 9 miles, or 10 miles. Do you guys understand what I'm saying? So maybe he ran 8 or less, or he might have run more. We don't know whether he fell on the 9-mile mark or the 7-mile mark. So we can't tell if we just use a random, we can't tell from the midpoint. The midpoint is not going to help us. So instead, what do? We do know for sure that one guy ran 10.5 miles or less. So, do you guys understand what I'm saying? I know for sure one guy ran 10.5 miles or less. How many ran 15.5 miles or less? Or less? 3. 2 in that group plus 1 before. Does everyone understand what I'm saying? So for 15.5 or less, it's 3. So that's why we use the upper class boundaries and the cumulative frequencies. Because the upper class boundaries, you know it's that much or less for that corresponding cumulative frequency. Why can't I use the lower class boundary? Because that would have to be the cumulative frequency of the class before it. Does that kind of make sense? So I don't want to say, well, use the lower class boundary and the cumulative relative frequency or the cumulative frequency for the previous class. That's just cumbersome. It's a lot easier to just use the upper class limits and the cumulative frequency for that class. Good? Everyone, does that make sense for folks? So here, we know that here's the cumulative frequencies. It'll be 1, 3, 6, 11, 15, 18, and 20. So if I were to draw an ogive for this, and I will, right here, then, okay, so ogives are trickier. I need to go from 1 to 20 on my y-axis, right, because it's cumulative. And along here, I need to go from 5.5 to 40.5. So I'm going to do it like that. Do you guys want me to give you guys the cleaner way or the boundary way? Because I can let you guys use the limits if you want instead of the boundaries. Do you guys prefer the limits versus the boundaries? Because here's the thing. if 10 is the highest that anybody could be in that class, then I know for sure, like the limits for this class are 6 to 10, 11 to 15, 16 to 20. So I know for sure that 10 or less, one guy ran 10 or less. 3 guys ran 15 or less. Do you guys understand what I'm saying? Because the upper class limit is the highest anybody can be and still be in that class. So we can just use the upper class limits if we want instead. So I'll do that because that's a little bit cleaner. But I do need to find the limit before because I do want to anchor it. So let's see if I'll show you the first part. 10, 15, 20, 25, 30, 35, 40. And then here we start at 0. 5, 10, 20. You don't have to label each one, that's okay. So here I'm going to have, this is 1, 3, 6. Oh, whoops, I missed one. Huh, my bad. 6. Okay, good. 11, 15, 18, and 20. So when you connect them, see that. But here's my problem, I'm not anchored. Okay, so here's the deal. How many people ran 40 miles or less? How many people ran 40 miles or less? 20. Does everyone agree with me? How many people ran 100 miles or less?
20.
Okay, so you've all run 40 miles. Say all you guys have run 40 miles. Which means you've all run 40 miles or less. Everybody on board with me? Have you all run 100 miles or less? Have you all run 1,000 miles or less? So once you hit this top part, it's still going to be 20 people no matter what. Did you guys see what I'm saying? Because if I get to 60 miles or less, that's still everybody. So once you get to 20 at the top, it's going to stay there. It's not going to drop back down. You wouldn't say, well, 20 people ran 40 miles or less, but none of them ran 50 or less. That doesn't make sense because they've all run 40, which means they've all run 60 or less, or 100 or less, or a million or less. 7, get that? So cumulative frequency, once you get to the top, you stay there. Everybody on board with that part? Because that's, you're saying, how many ran 50 miles or less? All of them. They all ran 1,000,000 miles or less. Do you guys understand this? Okay. But it's not anchored in the front. So I need to anchor my front because that should be anchored to the 0. So I have to go back, let's see, 20, 15, 10, 5. So I'm going to put a spot at 5. I'm going to anchor it there. Good? All right, so now I want all of you guys to do an ogive for your data, for the data in your quiz, on the back of your quiz. Good? Okay, so people have questions about data, and so I guess their questions were things like, well, do I use 15 or do I use 19? Well, your cumulative frequency is 4, so you can't say, so how many people, would you say that 15 people, that 4 people are age 15 or less, or would you say that 4 people are age 19 or less? 19 or less, right? So that's why you have to use the upper limits and not the lower limits. So we're going to use our upper limits. So along here we're going to have, we need to go up to 20. And here we need to go, give yourself a little bit of space here, and that's 19, 24, 29, 34, 39. And you have to label each one. You label every other one if you want. Okay. And then it started with 0. I'd probably go 0, 5, 10, 15, 20. All right, so this is what you guys have so far, hopefully. All right, so we know that 4 people ran 19, were age 19 or less. What's the next one? What's the next cumulative frequency? 11. 11 people were age 24 or less. And then 29 or less?
16.
16. How about 34 or less?
19.
19. And then it stays there for a little bit.
Yeah.
And then 40, for age 49 or less?
Yeah.
All right, but remember, we had the anchor in the front. So I need to make another imaginary one here. If 4 people were age 19 or less, can we say that no people were age 15 or less? Can we use 15? No, because some people might be age 15, and that they'd be in that class. So we could say no people were how old? 14 or less. We'd have to go down a little bit lower. And then we draw our line. And then again, it's going to stay constant like that forever. Good? I know mine's off a little bit. This doesn't look quite straight, but just roll with it. Okay. Then we had these graphs that deceive, right? Like non-zero axis. You guys remember? So this, if you're a Toyota Camry, would you be upset here? Yeah, looks like you're totally getting killed by the Honda Civic. But should you be worried? No, because you're at like 31 and they're at 36 or something like that. The difference is really not that great. If you look at the graph on the right is the accurate graph. You start the y. So remember, the y-axis should always start at 0. Now we don't care about the x-axis, but the y-axis, because that's your frequencies and stuff like that. That should always start at 0. So then you can really see the data and how it is comparatively. Remember, in general, people really like to, the people are biased, so they'll misrepresent data in a lot of wild ways. So I actually have a video for you guys to watch. We make a classic example of just that. Okay, ready?
But incredibly, Coke may actually have legal precedent on its side. You see, back in 1984, Kellogg's, the folks that make candy that you can mix with milk, decided that despite explicit recommendations not to, they put a label on boxes of all brand implying that it could ward off cancer, saying that their right to do this is protected under the First Amendment. Which made other companies say, wait, we can say what we want, okay, let's do exactly that then. Which is why Hellmann's once felt that they could put a smart choice label on their mayonnaise, and Cocoa Krispies boasted that they could increase your child's immunity, which is true, but only in the sense that it immunises them from not having diabetes. It's extremely rare for companies to be called to account for any of this. For instance, a few years ago, Kellogg's was forced to stop airing this ad.
A clinical study showed kids who had a filling breakfast of Frosted Mini Wheat cereal improved their attentiveness by nearly 20%.
Okay, 2 fun facts there. First, when they say nearly 20%, it's because they're rounding up from 11. And secondly, they were comparing kids who'd eaten cereal with a control group of kids who had no breakfast at all. And that is not so much a case for mini wheats as it is the concept of food. A much fairer slogan would be frosted mini-wheats. They're literally better than nothing. Clearly, we are now at a point where food companies feel no obligation to accurately represent what is in their products and what they do for you.
So, hey, just thought I would point that out. That was a kind of a humorous, fun one. Yeah.
Can I just say that that study actually makes it look even worse? It told me that someone ate and it only improved by 11%.
Yeah,
Like,
just under 11%.
They were basically still hungry.
And they say nearly, right? Nearly is sort of one of those fuzzy words we talked about in statistics before, like almost or, possibly. Nearly 20%. 11%. It's nearly 20. Yeah. So you had, someone else had a comment over here? So again, bias. That's crazy, crazy stuff. All right. Now, so go ahead and bust out your chapter 4 notes. Chapter 2 notes are going away. We're going to get our chapter 4 notes. Did anybody miss class and need chapter 4 notes? You need chapter 4 notes? Let me know, I can make a copy of them. Did they forget their chapter 4 notes? I need chapter 4 notes. Anybody? You guys all brought them? Really? Nice job, everybody. Well done. There's always a percentage, right, that will lose them or forget them. So I'm impressed that you guys all brought them. That's pretty darn good. All right. So just a couple reminders of some of the key things from last class from chapter 4. Probability of an event occurring when all events are equally likely. Incidentally, crashing in an airplane and not crashing an airplane. Are those events equally likely? You have two options. Either crash or don't crash. Does that make them equally likely? I get on an airplane. Is it equally likely that I crash or don't crash?
I mean, those are only two options, but what if you're talking about probability?
Yeah, I'm talking about probability. Is there a 50% chance that when I get an airplane, the airplane is going to crash? No. Does that make sense? So that is a situation where options are not equally likely. So everybody follow me? So all probabilities are not equally likely. The probability that I tie up for the 49ers and make the 49ers, actually they're doing pretty well right now. I was giving them a hard time when they were kind of sucking before. Even when the 49ers were horrible, the chance of me getting on that team is like next to nothing. Everybody agree? But either I make it team or I don't make the team. Does that mean there's a 50% chance that I make the 49ers if I try for the 49ers? Hell no. Right? Totally not. So all probabilities are not equally likely. But when events are equally likely, when they are, like I pick a number from 1 to 10 randomly, then all those numbers are equally likely to be picked. Everybody understand what I'm saying? Okay, when they are equally likely, then the probability is the number of ways the event can occur divided by the number of possible outcomes. I like to shorten that to number of successes over number of outcomes. With again that caveat that they have to be equally likely. So for example, we did this example last class. A bag of 5 blue marbles, 3 red, 4 green. The probability of picking a red marble, they're all equally likely. There are 3 red marbles, so 3 successes, out of 5 plus 3 plus 4, 12 possible marbles. Right, so this would be a 3 out of 12 probability of drawing a red marble. And again, I don't care if you simplify that or don't simplify it, not a big deal. We also drew a tree. Do you guys want me to remind you about drawing a tree? So remember, I drew a tree for like boy and girl. Right, that would look like this. Drawing 3 children. First child, boy or girl. Second child, from the bee. Boy or girl. Not from the middle or somewhere random. This is a branch floating in space. You can't do that. From the bee, boy or girl. And from the G, boy or girl for the second child. And then from each one of these. right? It's a tree, so they come off the previous branches. That's how these trees work. That way, you can follow along them to figure out how you get somewhere. If you do some crazy weird thing, where people kind of try to put them like that, it's like, how do you try to follow along, you just fall off into space and you go nowhere. You know what I mean? It's not helpful. These will help us solve problems in the future. These will help us figure out total sample spaces. These will help us find probabilities. Okay? So, you guys need to do the following. Draw a probability tree for flipping a coin 2 times. You're going to make 2 choices. What's my first choice? Heads or tails? Good. Then answer the 2 questions below that.